Hi everybody, this week we will be studying a method of logical proof called natural deduction. I thought we'd begin this week's video with a brief summary of Paul Herrick's introduction to chapter 18 on natural deduction. So, in natural deduction, we'll be arriving to conclusions about truth functional arguments by making a series of deductions. Remember, to deduce something is to conclude to it based on something else. In order to make accurate deductions this week and next week, we will be referring to valid inference rules. Any inference rule tells you how to make an inference of a certain type. To infer is to reason to something based on something else, and an inference starts with one or more statements and stops with one statement. An inference rule states that from one or more statements of logical form, you may infer a corresponding statement. In an argument, the statements you start with are premises, and the statement you stop with is the conclusion. So a valid inference is if the premises are true, then the conclusion is true. A valid inference rule, or a logical form, if followed correctly, will result in a valid inference. So we're going to be using logical forms or argument structures to draw inferences from variable arguments. This week we'll discuss the first 4 valid inference rules, and we'll learn how to apply them in the process of natural deduction. So we'll be using the first 4 rules to deduce a conclusion from a set of variable premises. On page 346, Herrick said, if a natural deduction proof exists for an argument and the inference rules used are valid rules of inference, then the argument must be valid. So let's go over the first 4 rules. The first rule is the modus ponens rule. You see, the argument form begins with a conditional. If P, then Q. P, therefore Q. The first premise is the conditional if P, then Q. The second premise is P. The argument form says, and the valid inference rule says, if P, then Q, and the second premise is true, P, then we can infer the conclusion, which is Q. You'll see the substituted instance, the variable argument, which follows the same structure as the modus ponens, is a valid inference based on the modus ponens rule. If A, then B, A, therefore B. Okay, let's look at the modus tollens rule. You see the form begins with a conditional. If P, then Q. The second premise of the argument is the negation of the consequent, not Q. What we can infer from the first premise and the second premise is the negation of the antecedent, not P. You see the substituted instance, if A, then B, not B, therefore not A. You'll notice it follows the same structure as the modus tollens form. Okay, let's look at the hypothetical syllogism inference rule. You see the first 2 premises are conditionals, and the conclusion is a conditional as well. The form goes as follows. If P, then Q, and if Q, then R, therefore, if P, then R. Again, if the first 2 premises of the argument are true, we can infer the truth of this conclusion, if P, then R, by rule. Notice the substituted instance. If A, then B, if B, then C, therefore, if A, then C. It follows the same structure. And now let's look at the disjunctive syllogism. There are 2 variations of the disjunctive syllogism valid inference rule. I've put both of them up. The first, P or Q, not P. Therefore, we can infer Q. The second variation, P or Q, not Q. Therefore, we infer P. You'll notice the 2 substituted instances follow the same structure as the 2 variations of the disjunctive syllogism valid inference rule. something else I want you guys to be aware of this week, and that is two fallacies to avoid. A fallacy is an argument form that is not valid. Let's look first at the fallacy affirming the consequent. The form states, if P then Q, Q therefore P. You cannot guarantee the truth value of the antecedent with those two true premises. Similarly, the fallacy denying the antecedent. That fallacy's form begins with a conditional, if P then Q. The second premise is not P. Someone might try to infer, therefore, not Q. You cannot infer a true negated consequent based on a true conditional and a negated antecedent. Both of these fallacies correspond to the modus ponens and the modus tollens. You need to be careful while going through the process of natural deduction. Careful not to mix the fallacy of affirming the consequent with the modus ponens rule, and the fallacy denying the antecedent with the modus tollens rule. Let's practice inferring a valid conclusion based on the four rules. You see, I've put an example up of an argument that follows the modus ponens structure. The first premise is a conditional. It states, if A or C, then B and Y. The second premise is the antecedent. It is the disjunction. Now, in the first premise, the horseshoe shows you what the antecedent is and what the consequent is. The antecedent is the disjunction, and the consequent is the conjunction. If the conditional is true and the antecedent is true, then we can infer based on the modus ponens rule that the consequent is true. This argument would conclude with the inferred conclusion B and Y. Let's look at the modus tollens rule. I've put up an example for you. It's not the case that A. Then, it's not the case that D or R. The second premise is, it's not the case that D or R. You'll notice in the first premise, the horseshoe separates the antecedent from the consequent. The antecedent is, it's not the case that A. The consequent is, it's not the case that D or R. In the second premise of this argument, you have a negated consequent. The statement, it's not the case that D or R, is negated in the second premise. Because of that, we can infer the negation of the antecedent based on the modus tollens rule. And so the conclusion would be, it's not the case that A, or tilde tilde A. Let's look at the example for the hypothetical syllogism rule. The first premise is a conditional. The antecedent is also a conditional. If A, then B. The consequent of the first premise is not R, tilde R. The second premise is also a conditional. If tilde R, then B or D. The consequent of the second premise is a disjunction. Now, you have the first premise, which is a conditional, and the second premise, which is a conditional. The consequent of the first premise is tilde R. The antecedent of the second premise is tilde R. Because the consequent of the first premise and the antecedent of the second premise are the same, we can perform the hypothetical syllogism. And therefore we can infer the conclusion. If A, then B or D. Okay, let's look at the disjunctive syllogism rule. The example I've provided, A and B, or C and D. The second premise, it's not the case that A and B. Because we have, in the second premise, negated the first disjunct of the first premise, based on the disjunctive syllogism rule, we can infer C and D. If we use this example in the second variation, A and B, or C and D, the second premise would negate the second disjunct. It's not the case that C and D, and we could therefore infer the first disjunct, A and B. Okay, let's put the first four valid inference rules to work in the process of natural deduction. You see the example. With the modus ponens inference rule, we can prove this argument valid, because if a natural deduction proof exists for an argument and the inference rules used are all valid inference rules, then the argument must be valid. So let's begin to put the modus ponens rule to work by finding the structural pattern in the argument. The first premise, if X then Y. The second premise, if Y then R. The third premise, if R then D. The fourth premise, X. And then you have that slanted slash, and after the slanted slash is a D. The slanted slash indicates the conclusion. So the conclusion of this example argument is D, and the final premise is premise 4, X. Now, let's start unraveling this argument with the modus ponens valid inference rule. You'll notice premise 4, you have a singular variable, X, and X exists as the antecedent of premise 1, the conditional if X then Y. If we look at premise 1 and premise 4 on top of each other, what you see is if X then Y, X. Based on the modus ponens rule and the true premise 1 and the true premise 4, we can infer Y. So you'll see the inferred premise, number 5, Y, based on modus ponens 1 and 4. Once we have the inferred premise Y, we can perform another modus ponens inference with premises 2 and 5. Premise 2 states if Y then R. Premise 5 states Y. We can validly infer R based on the modus ponens rule. Once we have R, we can perform another modus ponens based on premise 3 and premise 6. Premise 3 states if R then D. Premise 6, the inferred premise, states R. We can therefore validly infer D based on the modus ponens rule. To be clear, once you have inferred a premise and you've justified that inference with a valid inference rule, that premise can be used to complete other valid inferences. You'll see the inferred premise 7 is D, and that is the conclusion of the original argument. Once we've inferred the conclusion based on the valid inference rules, our proof is complete. That's all the work you need to do. Okay, let's practice one using the modus tollens rule. You see the argument. The first premise, if X then Y. Premise 2, if Y then R. Premise 3, if R then D. Premise 4, tilde D. The conclusion, tilde X. Now, what can we infer based on the valid inference rules? With premise 4 and premise 3, we can infer tilde R. You'll see premise 3 states if R then D, and premise 4 states tilde D. Because the premise 4 negates the consequent of premise 3, we can validly infer in the negated antecedent of premise 3, not R. You'll see it says modus tollens 3 and 4 right next to the not R. That is what justifies the inference. Once we have that not R, we can infer in not Y based on premise 2 and premise 5. Premise 2 says, if y, then r. Premise 5 says, not r. Therefore, not y. This is another instance of the modus tollens rule. And finally, once we have the not y, we can infer not x based on modus tollens 1 and 6. Premise 1 states, if x, then y, and premise 6 states, not y. Therefore, not x, based on the modus tollens valid inference rule. And because our inferred premise 7 concludes in the original conclusion, not x, our proof is complete. Let's do one for the hypothetical syllogism. You see the example. Premise 1, if a, then x. Premise 2, if x, then y. Premise 3, if y, then z. Premise 4, if z, then e. The conclusion, therefore, if a, then e. Now, what can we infer based on the valid inference rule, the hypothetical syllogism rule? If you look at premise 1 and premise 2, premise 1 states, if a, then x. Premise 2 states, if x, then y. You'll notice that the consequent of the first conditional in premise 1 is the same as the antecedent of the second conditional in premise 2. Because they are the same, we can perform the hypothetical syllogism rule and infer validly in the conditional if a, then y, based on the hypothetical syllogism premises 1 and 2. Once we have concluded in the conditional if a, then y, we can conclude in another hypothetical syllogism using the inferred premise 5 and premise 3. If you look at the inferred premise 5, if a, then y, you'll notice premise 3 says if y, then z. The consequent of the conditional if a, then y is the same as the antecedent of the conditional if y, then z. Therefore, we can infer if a, then z based on the hypothetical syllogism premises 3 and 5. And finally, we can infer the conclusion if a, then e based on hypothetical syllogism from premises 4 and 6. Now, if you look at premise 6 first, it says if a, then z. And then you look at premise 4, it says if z, then e. The consequent of if a, then z is the same as the antecedent of the conditional if z, then e. And we can conclude in the conclusion if a, then e based on a hypothetical syllogism premise 4 and 6. And because we have finished with the conclusion, our proof is complete. Okay, now let's do an example that utilizes the disjunctive syllogism rule. And this particular example will incorporate other valid inference rules. Let's look at the example. If x, then y, premise 1. Premise 2, tilde y. Premise 3, x or d. Premise 4, if d, then tilde c. Therefore, tilde c. Okay, so this one is, like I said, incorporating more than one valid inference rule. So you want to keep an open mind while you're attempting to find the structure embedded in the given information or in the first set of premises. You'll notice in the first two premises you have the means to perform a modus tollens. Premise 1 states if x, then y, and premise 2 states tilde y. Because premise 2 negates the consequent of premise 1, we can negate the antecedent based on the modus tollens inference rule premises 1 and 2. So our first inferred premise is tilde x, modus tollens 1 and 2. Now that we have a negated x, look back at premise 3, which states x or d. We can negate the first disjunct of that disjunction and conclude in d. which is our sixth premise, our inferred premise, D, based on the disjunctive syllogism, premises 3 and premises 5. Now that you have D by itself in premise 6, you can perform a modus ponens with premise 4. Premise 6 states D, premise 4 states if D, then not C. We can conclude not C based on the modus ponens rule, 4 and 6. Okay. For your assignments this week, I'd like you guys to do the exercises in 18.2 and the exercises of 18.3. I've chosen an example from 18.2 to show you, and I've chosen an example from 18.3 to show you as well. Let's look at the example from 18.2. In 18.2, you will be asked to perform the process of natural deduction to complete proofs based on the given arguments. I chose an argument with 7 premises. It's a lot of premises, and there's a lot of inferences we're going to make, but I'll take you through the process. First, let's go over the details of the given premises. 1. If A, then B. 2. If B, then W. 3. It's not the case that W. 4. If J, then I. 5. If S, then tilde I. 6. Tilde A, then J or Z. 7. S. Therefore, Z. Okay. Ultimately, we know we want to use the process of natural deduction to establish valid inference that will finish or stop with the conclusion. That will complete our proof. And let's begin by seeing what we can infer, by attempting to find the structure and the pattern embedded in the given information. You can start anywhere. I chose to start with a modus ponens. If you see premise 5 and premise 7, premise 5 states, if S, then not I. Premise 7 is S by itself. Premise 7 is the antecedent of premise 5 by itself, which means we can perform a modus ponens and infer tilde I as our inferred premise 8, based on modus ponens 5 and 7. Once we've done that, we can perform a modus tollens with premise 4. If you look at premise 4, it states, if J, then I. And premise 8 states, not I. Premise 8 negates the consequent of premise 4. And because of that, we can infer the negation of the antecedent. The inferred premise 9 is not J, based on the modus tollens 4 and 8. Now, after we do that, we can see that the not J will be useful. There is a disjunction. The disjunction is J or Z, and that's in premise 7. But that disjunction doesn't exist by itself. That disjunction is a consequent of a larger conditional in premise 7. We're going to need to get that disjunction by itself in order to infer Z by itself and complete the proof. In order to get the disjunction by itself, we'll need to get a negated A, so as to perform a modus ponens. So let's start working on that. If you go back up to premises 1 and 2, you'll see the means to perform a hypothetical syllogism. Premise 1 states, if A, then B. Premise 2 states, if B, then W. Because the consequent of the first conditional is the same as the antecedent of the second conditional, we can perform a hypothetical syllogism and infer if A, then W, based on hypothetical syllogism 1 and 2, as our inferred premise 10. Now, once we have if A, then W, we can negate the A. using the third premise of the given information. The third premise of the given information is a negated W. That negates the consequent of the inferred premise 10, if A then W. And because it is a negated consequent, we can accurately infer the negation of the antecedent based on the modus tollens rule, premises 3 and 10. If A then W, not W, therefore not A. So now we have our not A. Let's go back to premise 6 and let's affirm that disjunction by itself by performing a modus ponens argument. Premise 6 states, if not A, then J or Z. Premise 11 states not A. And so premise 12, we can infer J or Z based on the modus ponens rule 6 and 11. Once we have J or Z by itself, we can complete the proof. We have in premise 9, not J. And based on the disjunctive syllogism rule, we can infer Z. Okay. I also wrote out an example for you guys from 18.3. 18.3 combines your skills of translating with the process of natural deduction. So you'll be given arguments in English. You'll need to translate those arguments accurately, and then you'll need to engage the process of natural deduction. All right. I chose number 15 because the English argument is a little confusing. So I figured I would read it to you guys, show you how I translated it, and then we can go through the process of natural deduction together and complete the problem. The argument states, if Gilligan is late, then the skipper will be worried about his little buddy. I translated this first sentence as if G, then S. The second premise, if the skipper is worried about his little buddy, then the skipper won't eat. Premise 2, I translated if S, then tilde E. Premise 3, if the skipper won't eat, then Mrs. Howe will become concerned. I translated premise 3 as tilde E, horseshoe, H. Premise 4, if it is the case that Gilligan is late, then Mrs. Howe will become concerned. Then the professor will argue that Mrs. Howe's peace of mind is dependent on Gilligan's punctuality. I translated this sentence as, if G then H, horseshoe, P. So you have a conditional as the antecedent, and then you have P as the consequent. The conclusion. So, the professor will argue that Mrs. Howe's peace of mind is dependent on Gilligan's punctuality. You'll see I translated that as slanted / P. Okay, let's go through the process of natural deduction with this argument. If you look at premises 1 and 2, you clearly have a hypothetical syllogism. If G, then S. If S, then not E. We can infer if G, then not E, hypothetical syllogism 1 and 2. Now, with this information, we can infer another hypothetical syllogism with premise 3. Premise 3 states, if not E, then H. And premise 5 states, if G, then not E. Here we can infer if G, then H, hypothetical syllogism 3 and 5. With premise 4 and premise 6, we can perform the modus ponens, complete the argument with the inferred premise P based on modus ponens 4 and 6, and there we go. All right, you guys, that's all I have for you this week. I hope that you guys have a wonderful week, and please message me with any questions.